Okay, so I want to just show you some quick things, couple short things, should be super, super easy. And you'll have a quiz to take on Google Classroom. All right, 4 questions, not bad. All right, so you're going to see ones that say evaluate. So I want to show you what happens when you do something like this. And now there's a reason why this works. And to be perfectly honest, you don't really care. So I'm not going to show you. Okay, so if you really, really, really want to know, let me know and I'll explain it to you, but most of you don't care. Okay, so this is an exponent. So you got 5 raised to the log base 5 and 9 power. So this is the base of the exponent. This entire thing is the exponent, and then that's the base of the log. Okay, so here's the deal, guys. This is the base, right, of the exponent. This is the base of the log. Do you see how they're the same number? They're both 5, right? Well, if the base of the exponent and the base of the log are the same number, guys, then the answer is just whatever the other number is. So the answer to this is 9. Okay, there's a whole reason why it works. Most of you don't even care. Okay, so if I give you 2 raised to the log base 2 of 8. Okay, so the base of the exponent, the base of the log are the same. So what's your answer? Your answer is 8. Got it? Okay, so if I give you 10 raised to the log of 5, okay, the base of the exponent is 10, right? Well, there's no base here, but remember the base is 10, right? So the bases are the same, so the answer to this is 5. Pretty easy, got it? Okay, moving on. All right, so now if it looks like this, log base 7 of 7 to the 6th power. All right. Again, this is the base of the log. This is the base of the exponent. The bases are the same, so your answer is just 6. Your answer is the other number. Okay. So if I give you log base 2 of 2 to the 9th. Again, base of the log, base of the exponent. So your answer to this is 9. Good, bad, ugly? Okay, now the other part is we're going to solve with 1 log on each side. Okay, so we're going to do something pretty easy. So if I give you log base 3 of x plus 4 equals log base 3 of 3x minus 12. Okay, so this only works if there's 1 log on each side. Okay, so if you have 1 on one side and 2 on the other, we'll get to that next week. Okay, so remember, if there's 1 log on each side, so 1 log on each side. I hate this pen. Okay, all you're going to do is cross out the logs. Okay, guys, I'm literally going to cross out the logs. So all you're left with is x plus 4 equals 3x minus 12. And then you're going to solve that. Okay, so subtract x from both sides. Now, again, we talk about this all the time. You may be solving yours a different way, and that's fine. Okay, I'm going to add the 12 to the other side. I get 16 equals 2x. Divide by 2. So x is 8. Now, okay, so you have to be careful because this may not be the answer. You have to check them. Okay, so what you're going to do is you're going to plug it back in to the original. And you can't have a negative answer. Okay, so you can't have a negative answer. Now, I don't want to flip the page, so I'm going to come back over here. Okay, so right here, and actually, let me just flip it. We add log base 3 of x plus 4 equals log base 3 3x minus 12. Okay, so you're going to take your answer. We had x equals 8, right? Okay, and we're going to plug it right in here. This whole answer can't be negative. This whole answer can't be negative. X can be negative, but this answer can't be negative. So you're going to do 8 plus 4, which is 12. 12 is positive, so you're okay. All right, and then you're going to do this side. You know, 3 times 8 minus 12, which is going to be 24 minus 12, which is 12. That's positive. That's okay. Now, in reality, these two are supposed to be equal. So not only are you looking, are they positive, but they got to be equal. Okay, so let's try another one. All right. So log base, or just, we're going to just do log. Okay, and that's a base 10. So log of 6x minus 3 equals log of 2x plus 7. Okay. Again, there's one log on each side, so all we're going to do is we're going to cancel the logs out. So we got 6x minus 3 equals 2x plus 7. Okay, go ahead and solve it. Pause the video and solve it. When you're done, turn it back on. Okay, so we're going to subtract 2x from both sides. We get 4x minus 3 equals 7. We're going to add 3, right? So 4x equals 10. We're going to divide by 4. So x equals 10 over 4, which remember we have to always reduce, which is 2 goes into both of them, so it's 5 over 2. Okay, now you got to check them. Remember, you're going to take this answer and you're going to plug it into each one of these and make sure it's positive and then make sure they're equal. Okay, so we got 6 times 5 halves minus 3. Okay, remember this is really over 1, so multiply straight across. So 6 times 5 is 30. 1 times 2 is 2. 30 divided by 2 is 15. 15 minus 3 is 12. The answer is not always going to be 12. It's just a coincidence. Okay, so it's positive. Now let's do the other side. 2 times 5 over 2 plus 7, which gives me 10 over 2 plus 7, which is 5 plus 7, which is 12. They're positive and they match. That means that's your answer. Okay, now let's try one that might not work. Okay, so we got log of x minus 3. Again, I'm going to leave the base off. We're going to use base 10. And remember, the bases don't matter. They have to match, though, by the way. If this is like a 5 and this is a 2, you can't do this, and I'm not going to give you one, so don't worry about it. And then we're going to use 2x plus 1. Okay? So give it a shot. Come up with an x answer. Okay, so pause the video and just come up with an x answer. I'm going to show you what's going to happen. All right? All right, so hopefully you got an answer. Okay, so this is x minus 3 equals 2x plus 1. We're going to subtract x. We get negative 3 equals x plus 1. All right, we're going to subtract 1, which gives me negative 4 equals x. Now, this can be negative. It's okay for this to be negative, guys. When I plug it back in, it can't be negative. Okay, so when I plug this back in, you get negative 4 minus 3, which gives me negative 7. Right there, it doesn't work. It doesn't even matter what this one is, okay? But this is a negative answer, so this is not going to work. So that's not the answer. So what do we write when it's not the answer? Hopefully you said no solution, okay? So again, you need to plug it back in and see if you get a negative. Okay, so now I want to show you what I was talking about, that x can be negative. So I'm going to give you something really simple. So log of negative x equals log of 4. Okay, log on each side, cross the logs out, right? Actually, we're going to make that negative 4. Actually, that's not even going to work. Okay, so negative x equals 4, right? So divide by negative 1, x equals negative 4, so make sure you went back and made that a positive, okay? It didn't do what I wanted it to do, but oh well. Okay, so x equals negative 4. Okay, so now this one, the x is negative, correct? Oh, it'll still be okay. So when I plug this back in, I have the negative of negative 4. What's the negative of negative 4? Well, it's positive 4. So guess what? That's positive. It's going to work. Now, this doesn't even have an x in it, so I don't even have to plug it in. So your answer is actually going to be x equals -4. Okay, so what you're looking for is you're not looking for if x is negative, guys. You're looking for when you plug it back in, is x negative. So on this one, even though x was negative, when I plug it back in, it became positive, so we're okay. On this one, x was -4, but when I plugged it back in, I got a negative answer. Okay, so again, real quick, okay, when the bases are the same, so base of the exponent, base of the log, the answer is the other number. Okay, and when you have one log on each side, you're going to cross the logs out, set the two things equal to each other, and solve it. Then you got to plug it back in and make sure the answer in here is positive and then they're same. Okay, hopefully that makes sense. Good luck. Peace out.